Good evening, friends. Let us start another important aspect in this differential calculus, that is maxima and minima of functions. If you remember in the last class, we have seen increasing and decreasing functions. In increasing functions, we observed that as the argument x is increasing towards the right of the horizon, the height of the function, that is value, output value, is also increasing. F of x is becoming more and more as you traveled from horizon to the right side. Now, accordingly, f dash x also we checked in this function. F dash x is also increasing and fx is also increasing in these particular regions. That time we said this is increasing function. If f dash x is less than 0, even though x argument is increasing towards the right, if f dash x is less than 0, I'm telling, then function is decreasing. So increasing function, decreasing function, when you identified by f dash x definition, telling that if f dash x is greater than 0 during the journey, then you are telling that it is increasing. When it is less than 0, we are telling it is decreasing within the given specified interval. Now, if increasing trend, if it continues like that, is there any maximum point in the function, or is it continuously increasing like a strictly increasing function? Means it will never have any maximum value for definition. Is it like that? How to identify whether a given function is having a maximum point or not? Is it having a peak or not? If so, to reach the peak, what kind of conditions I have to meet? This is the topic now we are going to understand. Let us go to the whiteboard clearly and understand. Yeah. First of all, let me tell you that if a function, let us say if a function f of x, f of x is defined in an interval, let us say I, in interval I. In this interval, you are having some set of real numbers. It is subset of the real numbers. What is this I here? I is a subset of real numbers. In this subset, now you have defined your function. If, let us say, C belongs to I, if there is an element called C belonging to this interval, and f of C is greater than f of x for all other values, for all other values of x in this I, then f of C is called as maxima. Understood or not? What I did now, I have defined a small interval in a total big real number system. In this interval, I defined the function. Now I wanted to take a point in this interval such that f of C is always greater than f of x for any other values other than this C in the interval. So if I, let us say, is defined from x1, x2, x3, let us say C, x4, x5, like that I have defined. Now, just observe this clearly, x1, x2, x3, C, like that I am defining an interval. In this interval, f of C is greater than all other values. is greater than f of x1 to f of x2 or dot 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 anything. Here I am putting comma. Okay, this is comma. Here f of x6. So let me write this clearly here. So please understand one important point here, that it is f of c is greatest or greater, better word. Then f of c is said to be the maximum in that function. How I'm telling? F of c value is greater than f of x for all other x values within this interval. Similarly, if f of c happens to be less than f of x for all other values, in the interval, like I told you, what all I told, x1, x2, like this, c, then I said x6. Is it not? Previously check up once. In that case, f of c should be less than f of x1, it is less than f of x2, dot 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 f of x6. So that time what is fc called as? Fc is said to be minimum of the function. So now we have defined clearly f of c is said to be maximum if f of c is found to be the largest of the other values. F of c is said to be minimum if f of c is found to be the smallest of the other values. Okay. Next important point. If this definition, if we give, is it sufficient or still we have to give further? With respect to the derivative, we will give a definition. That will be very simple. For example, if f dash x is greater than 0, f dash x is greater than 0, then fx has a maximum in the journey. See, like this, if I am going like this is the point I am talking about. F of c. This is called increasing trend. No, function is increasing, so it is reaching a maximum point. Now let us say f dash x is greater than 0, satisfied. We have reached the point C. We are reaching the C. After reaching the C, I would like to cross check again whether is it the only point C or anything else is there. So for that, I will define one small interval around the neighborhood of the C. So to confirm, this is a very important point. To confirm C as the maxima, what I do? Define a neighborhood. Define what? A neighborhood. What we have already done in the previous sums. 0 to in pi, in between pi by 6 one interval, sorry, one value. Then 0 to pi by 6, pi by 6 to pi, like that we divided the interval. Here also, to confirm C as the maxima, define a neighborhood around C. How we are defining? Let us draw one line. This is C. We define in such a way that to the left of C and to the right of C, we define C minus H and C plus H. Two values, both belong to the I. C minus H and C plus H, both belong to I. We are not going out of this I. In your x1, x2, x3, x4, all that x6, C minus H, C plus H, all will be there. That time, f of C minus H should be, one second, should be less than f of C, and f dash C minus H should be greater than f Yeah, f of c minus h should be less than f of c. This f dash c minus h, don't worry. Next, f of c plus h, whatever this value is there. Here, what I'm planning to give you now is, here definition is f dash. F dash c minus h value should be less than f dash c. F dash c plus h value should be, this value should be greater. Please excuse me once. Here, small confusion. Now I'll tell you. What we are trying to tell, when the curve is increasing like this, here f dash x should be greater than 0, we are telling. So in the place of x, if I write c minus h, it should be greater than 0. So f dash c minus h should be greater than 0. This condition should be met. Here, f dash c plus h should be less than 0. Very, very important. F dash c minus h should be greater than 0. F dash c plus h is less than 0. And f dash c should be 0. If these three are met, then your point C is, then C is said to be maxima. Please understand, around the neighborhood of C, for maxima definition I'm giving. You confirmed, let us say C as the maximum point there. In that case, what we do, a neighborhood we define just around the C. When we are defining the limits, continuity, the particular video classes we observe, we define a neighborhood C minus H and C plus H. Compare F dash C minus H. Compare f dash as c plus h. One should be greater than 0, other should be less than 0. F dash c plus h should be less than 0. F dash c minus h should be greater than 0. And f dash c must be 0. If these three are met, c is called as the point of maximum. Now, for minima, how to do? To confirm c as minimum point, same way. Again, we define, this is for maxima, I will write. Same one neighborhood will define C minus H, C plus H. In this case, decreasing trend. So F dash C minus H less than 0. Here 0 na C na, actually we should write greater than 0 na, correct only. Should be greater than 0. Sorry. So therefore, that time F of C will be minimum and C is minimum. So here what is happening is, now I'll draw the full curve for you like this. This is called as C. Let us say I am traveling in this direction. C minima, C maxima. Here f dash x, here f dash x. Here it will be greater than 0, less than 0. F dash x should be greater than 0. Here f dash x is less than 0 in this direction when you are traveling. Decreasing, this is called what? Decreasing. Here this is increasing. Increasing function, decreasing function of the function. So when you are reaching this point C minimum, and when you are reaching the point maximum C here, what we are noticing is the sign of your f dash x is changing. Sign of the f dash x is changing through C. Sign of f dash x is changing through C when you are traveling through C. So f dash x is becoming less and f dash x is greater. This is a critical point for me. Left hand side, right hand side. Hope you are noticing this very, very important point. F dash x is less than 0, greater than 0. That will decide. If f dash x is not changing when you are passing through C, then that is called actually point of inflection. If f dash x is not changing its sign, while passing through C, then C is called point of inflection. So now what we learned? We learned 2 points. One is maxima, minima. Next, third one we learned point of inflection. So we understand that if by chance, if you define an interval c minus h, c plus h, and you traveled through them, when you're traveling through them, you understood that f of x, f dash x is changing the sign. When f dash x is changing the sign, then function is said to have a maxima and a minima. You can define like how we have shown in the previous this curve. If direction of f dash x or the sign of f dash x is not changing even after crossing this so-called point, critical point or C, then the point C that time is called as point of inflection. So f dash x will remain same value. F dash x, if it is remaining as greater than 0, even after crossing the C, it will remain as greater than 0. If you are crossing through minimum, even after crossing through minimum, f dash x will become less than 0. Crossing the C also, f dash x less than 0. So this is the main point. So maxima point, minima point, point of inflection, these are all called as critical points of function. What are they? Critical points of function. So now by observing this neighborhood of C around the point C, we are able to define whether we are in the minima, we are going to reach minima or a maxima. And we also put a condition that f dash x is 0 at this critical point. That is also we have told already. See, that is a very, very important point. F dash x is 0 at C. So at the critical point, there is no differentiation. Why? Because once you reach the maximum point, there is no variation of that point. It will change the sign and remain there. That is called as what? No differentiation point. It reached its peak. From the peak, it will change the course of action. Either it will be coming down or going to other direction, like decreasing to increasing. At the point where it is reaching the peak, the differentiation is said to be 0. This point we should remember. So f dash x should be 0, f dash x less than 0, f dash x greater than 0. These three are the points which will determine whether we are touching the maxima or minimum. Okay. So when we are doing the sums, we will be able to understand further. There is one more test to know whether we are able to get the maxima or minima. That is called second derivative test. That also I'll tell you clearly. Second derivative test for uh, identifying maxima and minima and maximum and minimum values of function. Values of a function. This one is very, very important. Here I will tell you step by step for you. Let f of x be a function. Okay. Find f dash x. First we have to do f dash x. Equate f dash x to 0. Then get critical points. So once we equate f dash x to 0, you will be able to solve an equation and you will get the critical points. These are called as points where you have got a feel that you are having a maxima or a minima or points of inflection. These critical points will decide. Next, find f double dash x. See step by step. First, this one. Second step is this. Find f double dash x. Then put critical points in f double dash x. If f double dash x is negative or less than 0 or negative, fx has maxima. Fx has maxima. F dash x greater than 0, or let us say this is a positive value, then f of x has minimum. Minimum at those points, at those particular critical points, at the critical points substituted. Okay. Then this particular value, once the sign decides whether function is having maxima or a minima, then that particular value you can put it in the function to get the maximum value or minimum value. So here I'm writing here f dash x less than 0. It will decide that f of x has maxima and fx has maximum value. Then f dash x is greater than 0. Then f dash x has minima and fx has minimum value. If f double dash x is equal to 0, then this derivative test fails. We have to, that time what we should do? We have to adopt previous neighborhood check. Please remember this to know that we should not do that time. So only one sum I'll do for this particular segment one, and then next we'll continue further. So one sum I'll finish now to identify the maxima and minima. Let us find out. Yeah, f of x is equal to find maxima and minima of f of x is equal to x square. Let us say one sum I have taken up now. In this, directly I will do by a substitution. F dash x is equal to 2x. Okay, directly f dash x is equal to 2x. Now f dash x is equal to 0. You equate 2x is equal to 0 came, x is equal to 0. That means function is having a 0. Here x belongs to real numbers. So if you see clearly, this function looks like this. Means what is this meaning now? Function has minima at x is equal to 0, but maxima is not there. Why? Because the interval they have given x belongs to R. So the function is ending, never ending, like it will go upwards. If it is not defined in any particular interval, bounded interval, then we cannot get a maxima here. This one maxima is not there because x belongs to R and no specific interval, no specific interval is defined. So minus infinity to plus infinity we can take. So when R is like this, it is going on. If you give a particular definition, let us say, if interval is, let us I have given 2, 4. Then I will say that at 2, I will find out the minimum value, or at 4, I will find out the maximum value. I can just say that this is the maximum value, this is the minimum value, like that. So when the interval is defined, we will be able to find out the maxima or minimum, because I can put these values and then find out. Okay. So if interval is not there, then you can only find out whether function is passing through the 0 or origin, and then what is the minimum value for this, what is the maximum value for this. Maximum value is right now infinitely it is going, therefore not defined. So friends, I will continue to do the sums based on this in my next video classes. Please go through the fundamental what I taught. That will be more useful in the next few sums. With this, we will be able to complete also after the next video class applications of derivatives chapter. Okay. Thank you.